Hello, welcome to another video in my software short series. I'm afraid this one isn't as short as the rest, but I think it's important to go through this topic completely. So today's topic is, what is NPR 7150.2? And if you don't know what that is, it's a document. It's a NASA document that governs the development, the software engineering of software at NASA and its contractors. And we care about this because it governs software development for NASA. But ultimately, what we'd like to do by applying this document is make safer, more quality software and that has better chance of success. So it captures software engineering best practices, and hopefully applying this would be value added to your project. So I'm putting this together because, to be honest, my group, Tech Fellows in the Office of Chief Engineer at NASA, we own this document. And I wanted to provide a summary or a quick understanding of the entire document so it demystifies the whole thing, rather than maybe having to read the whole thing, and also to clear up some common misconceptions. So my goal is to make this document less scary, less daunting, and hopefully that you'll gain an appreciation of the value for applying this to the projects. I'm going to attempt to go through the whole document. What is the standard? How to apply it? What are the software classes? What are all the shalls? There's 131 of them. And what shalls apply to what class, as well as what documentation products should be produced to go along with software. So what is NPR 7150.2? It is, as I mentioned, the software engineering requirement set for NASA and NASA's contractors or partners. And I put an excerpt here from a NASA policy directive just for reference, really, but it basically says NASA shall utilize a disciplined approach to software engineering, and the requirements for that are in 7150, which is what I'm going to go over. And so why use this? As I mentioned, to help make safe, quality, and successful software. And if applied properly, it can add value to an otherwise undisciplined process that has the potential for introduction of defects or maybe other unwanted outcomes. So this captures engineering best practices for software learned over time to apply towards the future. Some key points. This document applies to all NASA software, but not every requirement in it applies to every piece of software. The requirements apply per classification, and I'm going to go through that. So not all the requirements in the document apply to all software. A subset of them might. The other thing it helps to say is this document is completely tailorable, mainly at the project or center level. So my recommendation with this document best use this document as a checklist. The software lead should go through this and consider each one of the requirements in here for value added to the project and decide if or how the requirement in here should be implemented. And if it's not needed or there's no value in it, it should be tailored out. So keep that in mind, as well as with the documentation is tailorable. The other, I guess, common misconception is a question we get is, does this apply to Agile? And the answer is yes. It does. It applies to all life cycle models, and it does not dictate a particular life cycle model. So yeah, it applies to all. It's up to the project to apply the requirements in here to whatever life cycle model their project is using. So the document itself has chapters 2 through 6. Chapter 2 is 30 institutional requirements, which I'm going to go over, but really are not as much of the concern to the project. These are things that the organization or that NASA has to have in place to make software projects successful. I'll go through those. But the meat of this document is in chapters 3, 4, and 5, which has all the rest of the shalls. There's 101 requirements in all those. And my intention, like you see on this thumbnail, is to go through each one of these quickly and in groups to gain an understanding of the entirety of this document and what software projects should consider. And then I'll go over recommended documentation and tailor it specifically for small projects. The software classification at NASA. So for details of these classifications, I'm going to point you to the document itself. There's a lot of description and specific examples in the document, but I'm just going to itemize here what they are. So Class A is human-rated space systems, and Class B is non-human rated space systems, plus large-scale aeronautics. And I'm going to just say for classes A and B, all the requirements in this document apply. It's classes C and below where they start getting knocked down. Class C is mission support software or aeronautic vehicles, major engineering research facilities. 92 of the 101 requirements apply to that. Class D is basic science, engineering, design, research, and technology software. 64 requirements apply to that. As far as things that are non-IT, Class E is the lowest pedigree, I would say, where it's concepts, prototypes, technology, some research. Again, I point you to the document. And then the last class is Class F. This is general purpose computing and IT software, much like PowerPoint that I'm using, and 65 of the 101 requirements apply to that. Now to dig into the first 30 of the requirements. These are the ones in Chapter 2 that are called institutional. These are the things the organization should have in place and should be doing. I'm going to go through each one of these. First, I'm going to start with the Office of Chief Engineer, which is where I belong to, and it says what my office should do, and that is to lead the software engineering initiative, to benchmark each center's capability against this NPR, to benchmark the mapping matrices of each center against the NPR, to authorize compliance appraisals, to provide training, and to maintain a process asset library, which I'm going to give the link to at the end of this. The next organization that has responsibilities outlined here is Safety and Mission Assurance. And they have a very similar 6 that are analogous to the OCE ones. And that is they shall lead the software assurance and safety initiative to benchmark centers' software assurance capabilities and mapping matrices, to authorize appraisals against the requirements, to provide software assurance training, and also uniquely to SMA to make decisions on tailoring the IV&V requirement, independent verification and validation. So the next large chunk of this 30 all start with the words the center shall, center director shall. And what this means is the responsibility for these requirements been delegated to each NASA center. And it's usually not the center director, it's a delegate, usually maybe the software system manager or technical lead, whatever the title is, the person responsible for the software at the center. So just going through these, the center shall staff and advance software engineering, establish and execute software processes, comply with this NPR, and I'm going to go through the classification matrix in subsequent, I think in the next chart. Report project status, maintain a list of projects, shall maintain software metrics and use them for improvement. Establish and maintain a cost repo so that cost estimation is improved over time. Contribute to the agency process asset library. Again, I'll show you the link to that. Define the content of software documentation. Now, this is one of the things I mentioned that's tailorable. So at the center level can decide what type of documentation should be deliverable with the project. Ensure government rights to software, ensure that the reuse conforms to policies, maintain a contributor list of who built the software for invention purposes, and ensure proper transfer of the software outside of the center. So that's all the ones for the center. And now there's a few kind of unique ones at the end of this section. One key requirement is for the contract officer, there's a requirement there that basically says contract officers shall put this document on contracts. So that's an important link. The tech authority shall assess centers or projects against this NPR. Now, the tech authority in this case is normally two tech authorities, the software engineering and software safety and mission assurance. And then there's a statement that if tailoring has to go beyond the center level, then these organizations, OCE, SMA, and the Office of Chief Information Officer, they all agree on the tailoring. And then there's a project manager requirement. Honestly, I think it should go in the next section, but it basically says that software plans need to be updated if the classification changes. So that's it in a nutshell. That's the 20 institutional requirements. Here is them summarized, and we'll go on. Now the fun stuff. So on this page, I intend to go over all 100. There's actually 101, but one of these has two shalls in it, so I'm going to call it 100. So all this is the meat of the whole document here. So in chapter 3 is what's showing the things that say software manager shall. Actually, all these say software manager shall. Everything in chapter 3, 4, and 5. So most of this is on the software lead, but again, consider this a checklist. If it doesn't apply, you don't do it. But first of all, perform a make-buy. Should you build it or not? Develop a plan. Track your progress against the plan. Determine acceptance criteria. Determine deliverables. Define the milestones. Require developers to report status. And developers also to provide the product and metrics. And developer provide access to the source code. Comply with this NPR. Second column, tailor. You shall tailor. Map to this NPR, establish and acquire any off-the-shelf COTS, SCOTS, MOTS, establish the cost, and then there's a list of things, special cost things to make sure you don't forget to include, including software assurance. I think training is in there. Store the cost in a repo, develop a schedule, review the schedule with the stakeholders, developers to report on the schedule, and train your people. The project manager should classify the software A through F, maintain records of that classification, then plan software assurance and independent verification and validation. If you do IV, V, and V, you have to ensure the I and V, ensure that there is a plan, an IPEP, provide IV and V artifacts, and respond to IV and V findings. You have to define the safety criticality of the software. And then if it's safety critical, adhere to the software safety standard. If it is safety critical, there's a special itemized list, and it's called SWE 134 that has a list of things to do. Perform MCDC testing on safety criticality, critical code, as well as cyclomatic complexity. That's the one with the two shells. So then, if there's auto-generated code, plan that life cycle, receive the necessary information from the supplier. If it's safety critical, this is probably the most controversial requirement we have, perform CMMI, which is an external organization certification capability maturity model. I can go over that a little. No, I'm not going to go over that. You can look that up yourself. Identify reuse requirements, evaluate reusability, and then there's several cybersecurity requirements. Assess your cyber, identify the risks, implement protection, verify the protection, use secure coding practices, and static analysis, as well as to record adversarial actions. And those are all cyber, and then perform bidirectional traceability. So that's all what's in chapter 3. Now I'll go over chapter 4. So this is all has to do more with the life cycle. The other ones are sort of general planning, project planning. Okay, for the life cycle, establish requirements, map those to the overall system, include safety requirements, and track changes of those requirements, as well as corrective actions. Need to validate against the requirements, architect the software, review the architecture, design the software, implement and code it, adhere to coding standards while it's being done, perform static code analysis. Testing, unit test the software, make it repeatable, then develop a version description document, credit any tools. You have to plan and report tests, actually perform the test, and then manage the configuration, evaluate test results, use accredited tools, update plans, validate in high fidelity simulations or on the hardware itself, track code coverage, validate metrics during testing, regression test, test the safety requirements. And this one is really the only one that has to do with data, but it's develop and test data upload products and procedures, test your reuse or any COTS off the shelf. And then later in the life cycle, plan for maintenance and retirement, actually deliver the products, complete your verification, maintain the product, and archive it. So that's the whole life cycle. The end of this is the chapter 5, which is life cycle support. And I'm just going to rattle them off. So plan configuration management, track changes, identify all the items to be configuration managed, established CM procedures, maintain records, perform CM audits, develop release procedures, participate in audits, manage risk, determine risk, and manage risk. Then there's a requirement to peer review throughout the life cycle, the requirements, the plans, the code, the test, and follow a basic peer review process. Record the results of peer review. Then a software measurement, measure the software in various statistics, analyze the measurements, put the measurement data somewhere, compare measured versus expected, measure software volatility, and track defects. So those all have to do with sort of metric tracking. Oh yeah, and in tracking defects, determine the severity levels, high, medium, low. We have some guidelines on that. To assess the defects in reuse and assess any defects in process. So that's sort of the process continual improvement. So there we have it. This is NPR 7150 on a one-pager. And hopefully that was helpful. I'm going to go on and show you next how all of these go down based on classification. Next, I'm going to quickly go over the applicability matrix in Appendix C, which shows which of these requirements applies to what software classification. As I mentioned, they all apply to Class A and B. I'm saying all 100. When we go to Class C, you see some with a line through in purple. There's 92 requirements. You can see what was removed, IV and V, and the CMMI requirement. Some others. When we go to D, a lot more are removed. I'll just put them up there without going through them. Can look at them, put it on pause and look at them. And then lastly, E, a lot more are removed. There's only 12 requirements that remain for Class E. And then I did a separate slide here for Class F just to show this is the applicability matrix for the Class F software, which is the IT related software. The last chapter in this document that I wanted to go over is Chapter 6, which has no shalls, but it lists a recommended set of software documents. And these would be deliverables, but tailored by the center again. And what I've done here in the chapter, they list them all, but what I've done here is I'm grouping them mainly for the benefit of small projects, so that there wouldn't be so much of a documentation burden. My suggestion here is combine things into one document. In fact, for a small project, you could have one sentence for maybe each of these topics. But the first deliverable I would suggest and is required is a software management plan. And you can contain schedule in there, costs, test planning, safety plan, assurance plan, all planning type of things. And then an SRS should be written and an SDD. The SDD should contain software architecture. You can put in the same document the data dictionary, the reuse, and interfaces. But again, larger projects probably break these out into separate documents. Then there's the software test procedures and report, and the software release package, which would contain a version description document, a VDD, user's guide, and programmer's guide. So that pretty much takes care of the primary sets of documents. And as I said, I've combined them, but also throughout the project lifecycle, there's other products that should be generated and can be handled just through your normal reporting to management. And you can include in that the software change tracking, risk management, measurement, and regular status reports. So that's it for the documents, and I think the document. So that's it. I just wanted to flash up some references and talk about forward work. So if you can download the PowerPoints for this, I have a link to the document itself. And I did want to mention we have an accompanying handbook that goes with this document that's publicly available on the web. And what it does is it gives rationale, much more description, best practices, and guidelines for each of these requirements. Also available to internal NASA people is this SPAN, which is a asset library for each NASA center that we can all access each other's sample projects, templates, previous documents, and best practices. In terms of contacts, I think the best contact is true book owner of this, Laura Maynard Nelson, who's done a great job in owning this book and maintaining it and updating it. She just released this Rev D and is also under a reevaluation project for the next Rev. So she keeps this alive and relevant for us all. Also, you can contact myself and Tim Crumley, Tech Fellows for Software and Software Assurance. So in conclusion, I hope this was informative, gave you a good understanding, hopefully less daunting. Some closing remarks. Again, reminder to tailor, combine things make sense for your project. Follow-on work, we continually improve this document. Right now, we're reevaluating the CMMI requirement and actually trying to reevaluate all the requirements for value added. As always, we're open to suggestions for updates to this document as well as more of these videos. Thank you.